All right, in this video, we are going to learn the amazing product rule to use for differentiation. Now, before I teach you the product rule, I want to remind you of two rules you should already know, the sum and difference rules. The sum and difference rules say to find the derivative with respect to x of a function plus or minus another function. It is literally as simple as finding the derivative of the first function and then adding, again, or subtracting the derivative of the second function. That's the sum or difference rule. One of the easiest rules. Most kids don't even remember the rule because they just use it. But the product rule is very, very different. The product rule I'm about to teach you is to find the derivative of a function times another function. And most kids think, oh, well, it's just like the sum rule. I'm going to find the derivative of f, and I'm going to times it by the derivative of g. Well, no. Absolutely not the product rule. So, I needed to share that with you before teaching you the product rule, because I can't tell you how many kids mess it up. All right, so here is the product rule. The product rule can help us find the derivative of two functions being multiplied together. And of course, it's a typo. I just typed way too fast. All right. So many different ways I can explain this, but basically it's this. This is my favorite way of explaining it, and that is right here. The derivative of a function times another function, f times g, is the first function, just leave it alone, times the derivative of the second function, plus the second function left alone, times the derivative of the first function. So it's a little bit complicated, but once you start using it, you're going to love it. But again, you leave the first function completely alone. You multiply it by the derivative of the second function. Then you add. This time, you leave the second function alone, g of x, and you multiply it by the derivative of the first function. Now, keep in mind, the order of multiplication doesn't matter. So if you were to reverse any of these, you're okay. And also, the order of addition doesn't matter. So you're okay. So honestly, you could take the first function times the derivative of the second function plus the derivative of the first function times the second function left alone. And that technically is the same thing because all I did was reverse these two. But again, it's multiplication. Order of multiplication does not matter. But, don't ever multiply two derivatives together. That's wrong. Don't ever multiply f times g together. That's wrong. It's the first function times the derivative of the second. And then the derivative of the second function, the derivative of the first function times the second function. Another way of doing this is to allow u to be the first function and allow v to be the second function. Therefore, you take u times the derivative of v plus v times the derivative of u. But it's the exact same thing, right? I'm taking the first function times the derivative of the second plus, this time I'm going to take the second function times the derivative of the first function. I don't care how you look at it. I don't care how you write it, but you got to memorize this rule. It's very easy to do, but kids mess it up sometimes because they just don't follow it the correct way. All right, let's jump right to an example and see how unbelievably easy it is to use this rule. All right, so I got a function, 3x squared minus 2x, times a second function, 5 plus 4x. All right, let's find the derivative using the product rule. The product rule says leave the first function alone. There I go, left it alone. Multiply by the derivative of the second function. Well, the derivative of the second function is very easy. It's just 4. The derivative of 5 is 0. The derivative of 4x is just 4. Plus, now this time, I'm going to leave the second function alone, and I'm going to multiply by the derivative of the first function, 3 minus 4x. The derivative of 3x is just 3, and then I got to use the power rule back here. The 2 falls down, negative 4x to the first. All right, at this point, I have done. I've used the product rule. I found the derivative. But of course, I got to clean it up. Half of your time is going to be spent cleaning up. All right, let's distribute this 4, getting me 12x minus 8x squared. Back here, I got to do a whole lot of distribution. So I got a 15. I got a negative 20x. I got a 12x. And then I got a negative 16x squared. All right, now it's going to combine all my like terms here. So I got a negative 8x squared and negative 16x squared. That's going to be negative 24x squared. I got a 12x, another 12x, that's 24x, minus 20x, that's 4x. And then I got a very lonesome 15. And there you go. There is the derivative, f prime of x. Now, FYI, another way you could have done this without the product rule is to just multiply. If you multiply this original function out, you get 15x plus 12x squared minus 10x squared minus 8x cubed. Again, there's my 15x. There's my 12x squared. There's my negative 10x squared. There's my negative 8x cubed. Now, combining like terms, that's negative 8x cubed positive 2x squared plus 15. Now, if I did that first, then I don't need the product rule. I just need the power rule. The derivative would be negative 24x squared plus 4x plus 15, which is the derivative. But the product rule does work. Maybe you think the product rule is faster. Maybe you think the other way is faster. I don't care. Just find the derivative. But for this next problem, I have to have the product rule. You cannot do this any other way than with the product rule. I have 3x squared times sine of x. So I have 3x squared times sine of x. Some kids will actually say, let u equal 3x squared. Let v equal sine of x. And then they remember that the product rule says to find the derivative, you do u times v prime, the derivative of v, plus now you're going to leave v alone and multiply by the derivative of u. So if you need to do that to help you, I don't really care. It's fine, but let's just tackle it. All right, I'm going to leave u alone, so 3x squared. I'm going to multiply by the derivative of sine of x. The derivative of sine of x is cosine of x. This time I'm going to leave the back part alone. That's v, sine of x. I'm going to leave sine of x alone. And I'm going to multiply that by the derivative of the first part, which is a very simple 6x. Just be very careful that sine of x is a value. Don't multiply the x by sine of x. That's just bad math. All right, then at this point, all I got to do is clean it up, and there's not really a whole lot I can do to clean this up. I got a 3x squared times cosine of x. Nothing really I could do with that. Plus, now, to avoid anybody accidentally thinking that the x gets multiplied here, it doesn't. I'm actually going to put the 6x in front. 6x times sine of x. Boom, there you go. Now, in a problem like this, the product rule is a necessity. All right, whoops, sorry, I went a little too low there. All right, let's do another example here. Now, this is going to be a combination of the product rule and a difference rule. So first off, this front part, I will need the product rule first because I have 2x, I'll let that be u. I have cosine of x, I'll let that be v. And then this is just subtraction, right? So remember the subtraction rule just says find the derivative of the first guy minus the derivative of the back. So I don't have to do anything special with that, but I do got to use the product rule on this part, and then I'll just subtract the derivative of the back part. All right, so here I go. To find the derivative, I'm going to leave the first guy alone, that's 2x, times the derivative of the back, v, right? The derivative of v is negative sine of x. Now notice it's negative, so I threw it in parentheses. I can move that negative to the front here on my final cleanup work. Plus, now I'm going to leave v alone, cosine of x, and I'm going to multiply that by the derivative of the front, 2x, the derivative of that is just 2. Once again, please keep in mind that cosine of x is cosine of x. I'm going to put that 2 in front to make it cleaner. But now I'm going to use the difference rule that says, okay, now I'm subtracting, so I just got to find the derivative of this back part, and that's pretty easy. That's going to be negative 2 cosine of x. Now, I didn't need the product rule for that. That was just a single value. The derivative of sine is cosine, and then the negative 2 is just a constant rule. So now I could clean all of this up. I got negative 2x sine of x plus 2 cosine of x minus 2 cosine of x. Oh, I could clean this up even more because the 2 cosine of x minus the 2 cosine of x is nothing, 0, gone, dust in the wind. So I get negative 2x sine of x to be my final derivative. So again, good problem here because I needed the product rule in the first part, and then I could just use a single derivative on the back there. That was pretty easy. All right, let's take a look at one more problem. All right, once again, I got 2 square root of x times x cubed plus 5. So I'm going to let u equal 2 square root of x. I'm going to let v equal x cubed plus 5. And you know what also could be helpful? And again, you don't have to do this, but it could be helpful to write this as 2x to the 1/2, because if I do need to find the derivative, which I will, it'll help me to find the derivative. It's written as a power. All right, so the derivative of this function is going to be, here I go, leave the first guy alone, 2x to the 1/2 stays completely alone, times the derivative of the back. All right, the derivative of the back is going to be 3x squared. The derivative of 5 is 0, so again, 3x squared. Plus, now this time I'm going to leave the back guy, v. I'm going to leave that alone. I'm going to multiply the derivative of the front. So be careful, I need the power rule here. The 1/2 is going to fall down in front, so I got 1/2 times 2x. My new power is going to be negative 1/2, because when that 1/2 falls down in front, the new power is 1/2 minus 1, which is negative 1/2. So now I got a whole lot of cleaning up to do here. All right, so here I got a 2 times 3, that's 6. X to the 1/2 x squared. You are allowed to, this is an old exponent rule. When you're multiplying powers, you can add the exponents. So 1/2 plus 2 is 2.5. That's going to be 5/2. 1/2 plus 2 is 5/2. Plus, now back here, let's see here. This may take me a couple steps to clean up. First, I got x cubed plus 5. Then I got 1/2 times 2. Well, that's just 1. I don't even need to write that. And then remember, I don't like negative exponents, so I'm actually going to move that to the entire bottom, where it's x to the positive 1/2. All right, so let's see here. So a nice answer could be 6x to the 5/2 plus x cubed plus 5, all divided by x to the 1/2. But, I mean, I could keep using my algebra skills to make this look a little bit better. Let's keep going. So I got 6x to the 5/2. Now remember, when you're dividing by a monomial, you could divide everybody by that monomial. So I got x cubed divided by x to the 1/2. And then I got 5 divided by x to the 1/2. And I could keep going, right? I know, you got to keep going. You got to clean this up as much as you can. So I got 6x to the 5/2 plus, now right here, remember when you're dividing powers, you could subtract the exponents. So 3 minus 1/2 is 2.5. So I get x to the 5/2, because 3 minus 1/2 is 2.5, 5/2. Hopefully that makes sense, right? Plus 5 over x to the 1/2. And oh my goodness, I could keep going because now I got like terms. That's 6x 5/2 plus 1x to the 5/2. That's 7x to the 5/2 plus 5 over x to the 1/2. Okay, I think I'll stop there. A lot of cleaning up to do there. And you know what? I mean, if I really wanted to be a jerk, I could go ahead and say, hey, why don't we add these together by getting a common denominator? But, I'll save that for a later date. This video is really meant to just focus on the use of the product rule. So again, I like to go ahead and label the first part u and the second part v, and then it's very easy to remember, hey, u times the derivative of v plus v times the derivative of u. And then you could walk yourself through it. Just be very careful. The easiest part, let me start with that. The easiest part is honestly just using the product rule. Usually most kids don't mess that up. It's all the cleanup work that happens after that does make finding a nice, clean final answer a little bit tough. And we saw that in this problem. It took us several steps to get to a nice, clean final answer. So just take your time with that. Don't overdo it, but then, but also make sure you use algebra to make it look better. All right, guys, that's it for the video. Hopefully the product rule is simple. Sometimes you gotta do a little bit of work to actually put it into motion, but the actual rule itself is pretty simple. All right, see you in the next video.